everyone, welcome to my video. I am Divya Bharsakle, third year civil engineering, and today I am going to give you an overview on bridge engineering, its classification, components, design consideration, structures, and so on. So without wasting any time, let's get started. Now bridges are classified into two main categories. First one is the structural form and second its material. Now based on the structural form, there are many of them including beam, arc, truss, cable style and suspension. And each type exhibits different load distribution methods, aesthetic and its impact in the civil engineering application. Let's go forward with the first bridge, that is beam bridge. They are the simplest form in the history of the bridges and they mostly consist of horizontal beams supported by piles. Straightforward design, cost effective for shorter span and well suited for roadways and railways. The second is the arc bridge. As you can see in the photo, it is usually a curved arc structure efficient for transferring loads to the support. It is mostly used for aesthetic and structural integrity for crossing valleys and rivers. Next, the truss bridges, as you already know, they consist of triangular units forming a rigid framework. And this allows it to be lightweight structure with high strength to weight ratio. This type of bridge is usually suited for longer span. Now, the cable-stayed bridges feature one or more towers that support the bridge deck with cables. They are good for aesthetic and efficient for long and medium level spans. The next is the suspension bridge and usually consists of massive cables suspended between tall towers with vertical cables supporting the deck. They are preferred for long span and give a remarkable architect for challenging terrains. Now, moving forward to the next classification, that is based on material. Now, there are many materials such as timber, masonry, steel, concrete, and composite materials, each with its own advantage and construction method and its structural integrity. First one is the timber bridges, which is the most historical one used for short span. It is aesthetic and mostly used in lower load application. The second one is the steel bridges, which is the most famous one as we can see nowadays. They are used for high strength and ability to span long distances and transferring the load efficiently and easily. The concrete bridges are versatile and most of all cost effective, mostly used with reinforced and pre-stressed form, and they allow various designs to form architects, cable bridges and most of the structural bridges as we have seen earlier. Now coming forward to the components of the bridges. First component of the bridge is a deck. It is the surface where the traffic travels and it is usually made up of material like concrete, steel and timber. It supports the bridge load and designed for durability and safety. Then the arches are usually curved structural elements as you can see in the image. They efficiently transfer loads horizontally to their supports. They are usually used for aesthetic and structural strength and commonly used for long span bridge design. Now coming forward to the piers, they are the immediate support in multi-span bridges, transfer load from superstructure to foundation, and this kind accommodates various forces including wind and earthquakes. Now this next one is beam or girders. They are horizontal structural members that support the deck and transfer load to the piers and abutments, designed to handle bending moment and shear forces and gives stability and safety. The next one is the cables, which is high strength elements used in cable stayed and suspension bridges. Carry load from the towers, which allows flexibility and efficient load management. The next one is the bearing that allows the movement between the superstructure and substructure due to temperature changes as well as earthquake activities. The last but not least, foundation, which is also the most important component of the bridge. They are crucial for load transmission from superstructure to the soil beneath. The foundation can be shallow or deep depending on soil conditions. Now, we will be seeing the design consideration of the bridges. And the first one is the concept of economical span. Now, the economical span is basically the length that minimizes overall construction, maintains cost, while maximizing the structural efficiency, typically influenced by material choices and load distribution. The next concept is afflux. It refers to the increase in water level upstream of the bridge due to obstruction caused by piers and abutment, and proper design considerations needs to be done to avoid the flooding and ensure safety. The next one is high flood level. It is the maximum level reached by flood waters during extreme weather conditions such as flooding, and understanding this concept is essential to determine the height at which the bridges need to be constructed to prevent any damage. The next one is a scour depth, and it's basically the result of erosion around the bridge foundation, as you can see mostly in water bodies, and this is vital for ensuring foundation stability to prevent cracks and failures. Then the loads on bridges, which is the most important concept. There are many various loads including dead load, live load, environmental as well as earthquake. These forces are important for designing safe and structural strength. Then coming to the IRC load specification, which is basically Indian Road Congress, that provides the standard load specification to ensure the safety of the bridges. Now, I would like to conclude this presentation by stating that there are many failures of bridges in India, which is which shows and highlights that how important is it to follow the design specifications strictly as well as maintain the bridges, mostly in the area of the foundations, where it is most probably high risk to failures, cracks due to water bodies, soil erosion, and etc. Thank you.